Okay, we're talking about quadratic curves. Quadratic curves have some unique properties that we want to cover. So something looks like this. They all look like a U shape. Okay, and then one thing we want to point out is the extreme point that it reaches, we call that the vertex. And since they have a U shape, they all are symmetric. You could fold the paper and everything would be the same on one side of the line versus the other side of the line. So we call that the line of symmetry. And for functions that are in terms of x, so they will look something like, so there's a couple of forms that we like to look at. So there's the vertex form that has some number multiplied times x minus h, quantity squared, plus some constant. Okay, so this is the vertex form, and the reason they call it vertex form is because the vertex is right here in the equation. It's the value h comma k, and so you see it right here. This is the point h comma k, and then a kind of tells you the steepness of the curve, or and if it's positive, it's going up, and if it's negative, it's going down. If it's ever 0, then this whole thing goes away and you get just f of x equals k, so it would just be a flat line. So this is the vertex form. And then another form that you might see is called the standard form. And that's just ax squared plus bx plus c. So you have, this is the quadratic term, this is the linear term, and this is the constant. Okay, so it's just a number by itself with no x attached to it. What these tell you, so A tells you, again, whether it's going to go curving up or down. So it's like positive is a smile, and negative is a frown. And so you can tell the curvature that way. C tells you what the y-intercept is, because if x is equal to 0, right? 0 times anything is 0, 0 times anything is 0, so it goes away and you get f of x equals c. So c is your y-intercept. And if you just look at these two values, that usually on like a multiple choice test or something like that, you can immediately identify which curve is correct if you just knew those two things. But let's go ahead and look at also the linear term. The linear term kind of tells you where the center line is going to be at. And if you had c equal to 0, then the b value actually tells you kind of the width of the thing, as long as a is equal to 0, equal to 1. So there's some tricky things on that, but the one thing that a lot of people memorize is that negative b over 2a is equal to the line of symmetry, the x value for the line of symmetry. Okay, so this line right here is at the x value, negative b over 2a. And you can pull out what the vertex is even when it's in standard form if you just plug in this value. So you take negative b over 2a and then you plug it back into the function for x, and you can find out what the vertex is. So this vertex is at the point negative b over 2a, comma, the function evaluated at negative b over 2a. Okay, so that's, I know that's a kind of a memorization thing, and you may or may not help you, but the main thing to know is that A is positive, it's smile, A is negative, it's a frown. This is kind of some just quality things that you can know about quadratic curves. And vertex form is a good form that can give you exactly where the vertex is. Remember, it's going to be the opposite of whatever's here. So if you see something like x plus 3, the vertex is actually at negative 3, so it would be over here. And this one is exactly the same, so it's x plus 3 quantity squared minus 4 then I can tell you the vertex is at the opposite of this one, -3, and this one, -4. Okay, so that is it.